Welcome to Spring LIB.
Hi everyone, so what we have is again a spring-held follower that has a mass of 0.5 kilograms, and it moves back and forth as it interfaces with a cam that has a contoured surface with a radius that's equal to 0.5 meters, and the contour is given by z is equal to 0.2 times cosine 2 theta. We know that the cam is rotating at a constant angular speed of 30 radians per second. What we're asked to solve for is the maximum and minimum FZ forces the follower exerts on the cam, knowing that the spring constant of the spring is equal to 1,000 newtons per meter. And the way we're going to go about solving for this is using our knowledge of rotational and normal and tangential motion, and combining that with free body diagrams and developing equations of motion to solve for these minimum and maximum FC forces. So what we're going to do first is go ahead and solve for our z double dot. So we know that z is equal to 0.02 cosine 2 theta. Taking the time derivative of this twice gives us z double dot, which is equal to negative 0.04 times cosine 2 theta times 2 theta dot times theta dot plus sine 2 theta theta double dot. And by plugging in the information that we know, we see that theta, or z double dot, is equal to negative 72 cosine 2 theta. And for our theta min and theta max, we know that for our maximum case, cosine 2 theta will be equal to negative 1, and our minimum case is when cosine 2 theta is equal to 1. Next, what we can do is we can draw a free body diagram. So here is our spring-held follower. So here is our normal force, and here is our spring force that's pushing back, and this is our acceleration direction of motion. So just by this free body diagram, we can see that for any arbitrary theta, the spring will compress a distance x, and that's given by 0.02, 1 plus cos 2 theta. So our F, SP, which is equal to kx, is going to be equal to 20 times 1 plus cosine theta, because we know k is 1,000 newton per meter. So this gives us that when we do our Newton's second law using our free body diagram, we can see that the net force in z is equal to m times az, which is equal to n minus 20 times 1 plus cos 2 theta, and that's equal to maz. We know that maz is just 0.5 times negative 72 cos 2 theta. This gives us that n is equal to 20 minus 16 cos 2 theta. Now we'll be using this equation to solve for our minimum and maximum forces. So as I said before, cosine 2 theta, or this equation for n, is maximized when cosine 2 theta is equal to negative 1. And this gives us an n max, or Fz max, equal to 36 newtons. And this equation is minimized when cosine 2 theta is equal to 1. Therefore, we'll see that the n min, which is equal to our Fc min, is equal to 4 newtons. So these two pieces of information are our final answer.